Good evening, everybody. Today I'm going to talk about how can we enhance the efficiency and accuracy uh, regarding automated process-driven application, right? Using the data science and machine learning key concepts and techniques. Okay. uh, in here, I'll be taking a real-time application, which I am working on these days, and I would like to share those things with you, and I'll show you how can I achieve some sort of things on that project actually, and I'll show you how I use my knowledge into this application as well. All right. So the first question is, what is data science? So data science is a field uh, uh, that actually uses scientific methods, algorithms, and some systems to extract knowledge and insights, right, from structured or unstructured data. So and it will combine statistics, mathematics, programming, and other related things like machine learning as well to analyze the uh, data and clear the complex data as well, right? So that is basically data science. And so there are so many sub-related fields included in data science, right? All right. First one is data collection, right? That is basically means the gather data from different sources, right? From databases, APIs, and sensors, actuators, uh, and many more, right? Okay. So uh, second one is the data cleaning, right? So data cleaning is basically handles missing values. Sometimes it removes duplicates, and the major thing is fix inconsistencies, right? Okay. Third one, data transformation and conversion. uh, this basically means the conversion of data into some usable formats. Example are categorical or numerical or something like, right? Okay. So fourth one, data merging and integration. So in here, we are combining multiple data sets if needed. Okay. In my application as well, I use I have used this method for this data merging and integration methods to develop my data set, right? All right. So then fifth one, data analysis, right? So this means the understand the trends, distributions of correlations, p-values, and all those things about the data set, and get some uh, insights about the data set, right? So finally, the feature engineering, that basically means the create new meaningful features into uh, the model to improve the performance of the model, right? Okay, let's move on. What is machine learning? Machine learning is the process of basically teaching computer to learn patterns from the data and make predictions. That is basically machine learning. As well as the machine learning also has so many sub-related fields, right? Actually, not related fields. Those are steps of the process, right? As I told previously. So I'm starting from the seventh point. So this is the seventh step, right? So seventh step is model selection and training, right? This basically means we are applying machine learning algorithms into the models and test different algorithms, right? That is basically model selection and training, right? So eighth one, evaluation and optimization, right? So uh, in here, we fine tune the model. Uh, how fine tune means the fine tune the hyperparameters and the features and the feature selections as right. Final one, the deployment. Deployment means the implement of the model into a real world application. And finally, we can iterate again, right? Back to second step means data cleaning step, if needed, right? Okay, that is the steps we needed to uh, uh, combine the data science and machine learning together to implement something on those fields, right? Okay, then let's move on. All right, so now onwards I'll take going on project, right? This is a going on project that I am doing these days actually, and this is going to be implemented as by using data science and machine learning techniques, right? So I'll explain this first, right? I am doing a project in the section of factory. There are three sections. First one is extraction. There are three major sections in our factory. First one is extraction. Second one we call it process, and third one is we call it tower. Right. Currently, I am work with this project in the tower section, and in here I am working, which is done in this tower. The product liquor, there is a product liquor converting into the powder at this section, right? Something like that, okay? So there are so many fluctuating variables, means not steady variables, right? Which are involving when the product liquor turns into the powder state, right? So the parameters are like somewhat related to, in a process there are some pressure values, temperature values, some percentages of mixtures, right? Dry solidity percentage, there is a dry solidity percentage parameter, mixing speeds, flow rates, moisture, many more, right? So I'm not going to explain everything in here. Think some parameters are there which involves to the process. That's it, right? So for this analysis process, I have created the software, right? Uh, I have created a software that can be used up to the end of the machine, by using machine learning model training steps up at the end of the model training steps, right? And I have talked about previously as well. And this software can be used from a person who even don't have the data science and machine learning skills actually. All right. Okay. Let's talk about the software first, right? Okay. As you can see in this slide, this is the interface, right? This is the interface of the software application, and this is designed by using actually the programming language is Python, and I have made this GUI by using PyQt 5 library, right? By using PyQt 5 library. This software I have shown in here. There are 4 steps, as you can see right now, and this I designed for the people who willing to use this one, and uh, actually with the lack of knowledge of machine learning and data science, right? And they can use afterwards. I left this space, right? That's why I created this software, right? Okay, let's discuss step by step of the process analysis uh, from the upcoming slides. Okay. All right. First one is data collecting, right? Our first step is, as you can remember, the data collecting part, right? Okay. Regarding this step, I have collected most relevant 13 parameters, right? I have collected 13 parameters which are acting inside the process, including the target variable, yeah, right? So there are 12 parameters, independent parameters, and one variable, right? One variable is the target parameter, right? Okay. So uh, inside that process, within an year data I have collected, right? Again, අවුරුද්දක data ප්‍රමාණයක් මම එකතු කරගත්තා. It took over, I think, 600,000 of raw data actually. And I took that much of data due to the certainty of the state of the process, right? And this much of data should include uh, the majority percentage, right? Majority percentage of incidents, right? Majority percentage of incidents that happen when it executes. ඒ කියන්නේ අර process එකක් කියන්නේ ගොඩක්ම again fluctuate වෙන ගොඩක්. So I need to capture every every little incident, right? Otherwise we can't predict the states actually, right? That's why. All right. Okay. Then the second step is the data cleaning part. So in here, I clean the data individually according to the format they existing, right? Okay. This basically means remove the outliers as you can see, and as I uh, explained earlier, remove the outliers and uh, undesirable data points from the dataset. That is the target. Okay. For that process, there are two popular, widely using methods, right? First one is Z-score method, right? First one is Z-score method, and second one we call IQR method. IQR means interquartile range, right? Interquartile means, as you know in our O levels, uh, Q1 and Q2 and Q3, those are the variables that we have taken to analyze this process, right? That is interquartile range. Okay. According to the Z-score method, we are talking Z-score method. We have taken the Z-score for every and each, right? Every and each data point, and uh, removing them if exceeds the maximum level, right? This depends on the parameters actually, and this margin should find by using the visualizations of the all dataset, right? Visualizations of the all dataset. In here, as you can see, this is the with outlier chart, right? This one with outlier chart, and this also have been given by the software. Actually, I designed the software to give those two figures, and after cleaning, uh, this one is the cleaned data set, data using the Z-score cleaning method. All right. So this is the Z-score cleaning method interface of my software, and as you can see, there are so many outliers inside the without cleaning figure. So as you can see in here, there are some outliers are removed from this Z-score cleaning method. All right, let's move on. Okay, when it comes to IQR method, IQR means, as I explained earlier, interquartile range, right? Uh, this is unlike the previous method. Uh, this will take the interquartile ranges like I said earlier, like as we know in O levels, we are taking Q1 and Q3 and removing outliers by using those quartile ranges by converting into another range, like 1.5 times Q3 minus Q1, likewise. Okay. So this previous constant 1.5 again depends on the parameter that we are gonna clean, right? In here, uh, actually in here as well, we use the all data visualization parts to determine what actually the constant that we are gonna use for remove the outliers, right? Okay. Okay, in here as well, this is the with outlier figure again, and this is the IQR method clean data, right? Okay, this is the interface, and this is the process log as well. All right. Then there is an issue. Our process, most of the data parameters are captured by the different level of sensors actually, and sensors and actuators as well. So those physical sensor values depends on the somewhat the state of the sensor according to actually according to the state that they are experiencing, right? According to my experience as well, it most of the cases it depends on the state, right? For an example, think according to a pressure sensor, right? Pressure sensor එකක් තියෙනවා. Now we are going to take that pressure sensor and it will give the value related to its physical measuring, right? Uh, this there is spring load related to that pressure sensor, and this spring load detecting criteria will give some outliers values, right? Outlier values uh, means somewhat incorrect, right? Incorrect values at once. Uh, depends on the pressure right now. Right now means the state that they are experiencing. So okay, um, so how could we remove those values, right? In here, this is another cleaning method. I designed this method to remove that kind of outliers from the fitting model, right? And I used polynomial model with 3 or 4 degrees, and then it looks like this, right? Okay. As you can see in this line, right? This one, right? Uh, is the predicting value line of the trained polynomial, right? So this is a 3 or 4 degree uh, polynomial model that I fitted to the dataset, and and this model method will cut down the outliers related to the predicted line, right? Predicted line. At this state, right? ඒ කියන්නේ අර මෙතන කලින් ඔයගොල්ලෝ දැක්කා වගේ කියන ගොඩක් outliers කැපිලා තිබුණ නැහැ, right? So outliers ඕන train model එක train කරන outliers යම් ප්‍රමාණයකට ඕන, හැබැයි අනවශ්‍ය තරම් අවශ්‍ය නැහැ. මොකද මෙතන ගොඩාක් data points තියෙනවා. We have so many data rows, so we need to cut down as much as possible we can, right? So for that reason, we need that kind of varying line, and related to that line, we need to take the distance. අර සමහර sensors තියෙනවා කියන්නේ spring load එකත් එක්ක යන සමහර sensors වලට ඇත්තටම අවුරුදු 15ක් විතර පරණයව තියෙනවා, ඊටත් වඩා ඒවා තියෙනවා. So එතකොට අර ඒ වගේ mechanical mechanisms පාවිච්චි වෙන sensors සමහර ඒවා තියෙනවා. So එතකොට අපි හිතමු මොකක් හරි pressure එකක් ගත්ත වෙලාවක එතන තියෙන outlier එකම තමයි, ඒ කියන්නේ outlier value එකම තමයි තව තැනකදී වෙන්නේ. එතකොට අර එකම range එකක අපි cut down කරන්න ගියොත් අර outlier එක කැපිලා යන්නේ නැහැ එතන. අන්න ඒක තමයි මෙතනදී වෙන්නේ, right? So that is uh, that is the basic thing that I have implemented into this parameters in our factory. Okay, let's move on. As you can see in this slide, uh, the data set with the outliers and without outliers. Uh, this is the with outliers, and this is the without outliers. I'll let me show you the difference between those graphs, right? Okay. Let me go back. This is the score method. So there are some outliers in here as well. So in IQR method, there are so many outliers in the this level of readings. So, but in here, you can see this model will cut down those outliers as much as possible. All right, let's move on. Okay. In here, what I have done is the previously we have cleaned the individual parameters, right? But in here, uh, now I am going to merge them all together. For that, I have taken the correlation and p-valued matrices. All right, p-valued matrices to merge them all. Means think the sensors are taking values from different places right now, but all values are not relevant to the same liquor content, right? So that's why we have taken those parameters individually, right? Then uh, merge them by taking correlations and p-values, by checking the correlations and p-values, valued matrix, and finally I merge them all together, right? In here, there are so many non-values, right? Non-values because of they have uh, only merged right now. No interpolations, no interpolations are applied, or no removed the non-values yet, right? Uh, ඒ කියන්නේ අර කලින් කියපු කතාව මම ආයේ විස්තර කරනවා නම් මෙතන එකම මොහොතේ අපි හිතමු එකම ටයිම් එකේදී සෙන්සර්ස් තියෙන්නේ සෙන්සර්ස් අපි හිතමු 12ක් තියෙනවා කියලා ඒ 12 තියෙන 12 තැනක. සෝ එතකොට ඒ එකම මොහොතේ එකම ටයිම් වැලියු එකට අපිට මර්ජ් කරන්න බෑ ඔක්කොම data කියන්නේ පැරාමීටර්ස් ටික. මොකද එකම liquor content එකට නෙවෙයි ඒ data points තියෙන්නේ වෙන වෙන ටිකකට. So we need to shift those parameter columns and need to check the correlation and p-values. The maximum correlated and the p-valued state is the best state to fix, right? That is the key idea behind that. All right, so let's move on. In here, what I have done is interpolated the missing values according to the particular columns, and finally remove the I actually finally removed the top and the bottom non-values as said, right? Interpolate with the සාමාන්‍යයෙන් between values දෙකක් අතර තමයි interpolate වෙන්නේ. එතකොට අර උඩම තියෙන values ටිකයි යටම තියෙන values ටිකයි we can't get the interpolation. So we need to remove all the top values and the bottom values from the data set. And finally, it is something like that, right? Okay. As you can see in here, there are 1.5 million rows, and most correlated I have taken most correlated 10 independent parameters in here, right? So that I found by applying the principal component analysis method in here. I'm not going to talk about much about that. And there is one dependent parameter and 11 independent parameters as well. All right. So then those are the correlation and p-value metrics. And as you can see in here, all the variables are gave approximately same weight. නේද? අර ගොඩාක් correlate වෙලත් නැහැ to for the for vary the target variable. So means the target variables means the dependent variable, right? According to the left side one, this actually says it has a good correlation if the absolute correlation value is greater than 0.0, right? Or it has moderated correlation if the absolute correlation value is in between 0.3 to 0.7, and if less, the relationship of the parameter is less, right? That is the idea. According to the data we used, we have received some moderated correlations in here, right? But think the correlation is less somewhat, right? Correlation is less somewhat, and the p-value is less than 0.05 as well. So that basically means the relationship is less, but can't ignore can't ignore that value from the process, right? That is the key idea, right? So uh, it basically means that those variables should apply to the model to train, right? Okay. uh, I'm gonna explain that key idea by taking an example. Okay, I am taking the v equals IR equation, right? V equals IR equation. We know uh, we have a directly proportional relationship with I and R, right? That is the key idea regarding that equation. But think we are doing a practical uh, and keep the I as constant in here, and taking the V by changing the R values, right? Okay, that is the scenario. And afterwards, we willing to take the correlations in between each and every parameters. That is the thing that we are going to do, right? So what will happen? The correlation with I and V is gonna be zero due to that values we have taken. But they have a relationship නේද? අපි දන්නා එහෙම relationship එකක් තියෙනවා. But it have taken the zero correlation, and we know it has a strong relationship with I and V. අපි අර මම එක ආයෙ පැහැදිලි කරොත් V සමාන IR කියන රිලේෂන්ෂිප් එක අපි දන්න හැකියම අපිට වැලියුස් ටිකක් දෙලා තියෙනවා. ඒකෙන් අපි රිලේෂන්ෂිප් එකක් ගන්න තමයි හදන්නේ කොරලේට් කරලා. So I කියන එක මුළු අපි ගත්ත හැම වැලියු එකටම එක සමාන නම් V කියන එක I R එක හොඳ කොරලේෂන් එකක් හදනවා තමයි. හැබැයි I එක තියෙන කොරලේෂන් එක බිඳුවක් කියලා තමයි දෙන්නේ. හැබැයි අපිට එහෙම නිසා කියන්න බෑ. ඒ කියන්නේ අපි ගත්ත දැනටගත්ත වැලියුස් හින්දා අපිට කියන්න බෑ මේ රිලේෂන්ෂිප් එක අයින් කරලා දාන්න පුළුවන් කියලා. Right? That's why I have taken those both p-valued metrics and correlation metrics, right? To analyze to uh, take the uh, major dependencies, right? Okay, to the target variable. All right. Let's move on. Okay. And I trained the model, and those figures shows the training loss and the mean absolute error for the training data set and for the validation data set as well. So this process took more than actually I think 8 hours to train for 30 epochs, and finally I took 0.89 R2 value for the model, and that value is pretty nice according to our application. And finally, mean absolute error was 0.019, I guess, after evaluation, right? Okay, so let's move on. All right. From here, let's see how I can achieve the solution finally, right? Okay, those are the components that I can show you here. And this is the Semantic S7 1200 PLC. And this is the Semantic ET200 SP RIO portal. RIO means remote input and output portal. And we can connect every input and output analog or digital connections into this portal, and PLC is the only the signal identifier, right? And identifier and the receiver. Okay, let's move on. This is the power supply, and this is the Ethernet signal connection interface. This basically make the connection between the PLC, RIO portal, and my PC, right? Okay. Right. So, the all right. This is the loop precision calibrator, right? Which can actually sense the signal and identify the receiving signal as well. Actually, it means this tool can simulate the situation, right? Simulate the situation. So there are two types of signals can be identified from the VLC system. Uh, first one, uh, first one is 0 to 10 volt signals, right? 0 to 10, right? 0 to 10 volt signals. And the second way is 4 to 20 milliampere range, right? 4 to 20 milliampere range signals, right? All the sensors and all related stuff sending signals into those two ranges, right? And PLC is going to be identified the values by using those ranges, right? The PLC also can identify the values that are received from the uh, sending tools, right? Think for an example, the temperature sensor is giving 4 milliamperes for 30 Celsius centigrades, right? And 20 milliamperes for 20 milliamperes for 230 centigrades, right? Now think if the receiving signal is 15 milliamperes, that is basically means we can find the value by scaling the temperature, right? අර මේ වැලියු එකකින් ඉඳලා මේ වැලියු එකට මෙහෙම රේන්ජ් එක යනවා නම් අපිට 15 කියන්නේ කීයද කියලා හොයාගන්න පුළුවන් එක ලීනියර් රිලේෂන්ෂිප් එකක් තියෙනවා නම්, right? That is the basic idea uh, inside that, right? Okay. All right. Thawa that the likewise we are giving only 0 to 10 volt or 4 to 20 milliampere analog inputs to the PLC system uh, regarding analog signals and receiving signals same to those ranges. And this calibrator also doing the same, right? Okay, this calibrator also uh, simulating the situation. All right, that is the basic thing that this pressure loop calibrator does. All right, let's move on. So now here I used the Python, right? The Python Snap 7 library to read and write the signals uh, that from the PLC, and we can access the PLC data through this library, right? That is the basic idea regarding this. Okay, so that is actually means we can program the PLC by using Python according to the all of the components uh, like sensors and actuators and many more, right? Uh, so from this Python programs, so then we can include our model to decision making process. So and we can get the dependent variable and according to that we can adjust independent parameters according to required position that by using the model that we decide. ඒ කියන්නේ PLC system එකක් කියන එක අපිට Python වලින් access කරන්න පුළුවන් receiving signal, sending signals, ඒක digital analog දෙකම ගන්න පුළුවන්. So then we can send the signals through PLC by the operation devices of a computer, right? That is the basic idea. ඒ වගේම මෙතන අපිට Python වලින් signals එලියට දෙන්නත් පුළුවන්, එන signals බලන්නත් පුළුවන්. කියන්නේ මේ library පාවිච්චි කරලා ඒ කියන්නේ අපිට model එකක් ඇතුළත් කරලා අපේ තියෙන parameters අපි හිතමු 10ක් තියෙනවා කියලා. ඒ 10 values අපිට change කරලා අර predicted parameter එක model එක පාවිච්චි කරලා අපිට predict කරන්න පුළුවන් මෙතනින්. හරිද? then අර කරන්න පුළුවන් එකම දේ තමයි PLC system එකක් දැනට පාවිච්චි වෙන විදිය තමයි normally කෝඩ් කරා ඒ ප්‍රෝග්‍රෑම් එක ඒ විදියට රන් වුණා. errors තියෙනවා PLC එක පැත්තෙන් නෙමෙයි, ඒ කියන්නේ sensors පැත්තෙන් ඒ පැත්තෙන් errors තියෙනවා, but අර මේ වගේ දෙයක් අපිට පාවිච්චි කරලා පුළුවන් පැරාමීටර්ස් ටික මොඩල් එකට අනුව වෙනස් කරමින් අදාළ ඩිසයිඩ් රේන්ජ් එකට අපේ ඩිපෙන්ඩන්ට් පැරාමීටර් එක ගේන්න. Right? That is the basic idea regarding this project, right? Okay. So have a look into this video first. This is the physical input button, right? Push button, and have a look how this physically actuated thing uh, occurs to another thing. All right. So let's see how that execution part will be done by using the program, right? Okay. All right. Let's move on. Okay. In here, we are going to see the output signals, the receiving signals, right? And how it took from the precision loop calibrator, right? Okay. Look into this video as well. In here, I am giving 19 milliampere signal into the PLC, and this PLC will sense that signal through some uh, pin into this precision loop calibrator, and it will show up to third decimal point correctly, right? Second decimal point correctly, right? In here, as well as you can see, there are 7.56 milliampere signal, and see what is the value that is displaying inside the precision loop calibrator as well. So these components are very reliable components, and we can take the signals up to second decimal point accurately. All right, let's move on. In here, we are going to give some inputs, right? This basically means source control. Uh, okay, have a look into that video as well. So this is the source mode, simulated mode, and measure mode, right? So we are going to give some input values from the fluke, and it will give 4 milliamperes into that RIO portal, and RIO portal will sends that signal, will send that signal into the PLC, and PLC will send that signal into our PC system, right? And PC system detects that value like here. As you can see, there is 4 milliampere signal is indicating, and when we change those values, all right, when we change those values, as you can see in this program, it will also indicating, it will be indicating the values that we are giving, right? Likewise, now we are going to change those value from very little bit of amounts, and it will also send in those signals very accurately, right? So in here, now we are going to have a look about inputs and outputs, source control and signal receiving things, right? Okay. In here, as you can see, there is a 19.99 value, right? Means 20 milliamperes, right? Okay, when it change into the 16, it will indicate in 16, and the voltage signal I adjust them to 0 to 10 means this actually means the 4 to 20, right? 4 to 20 means the range. So there are 16 values. ඒ කියන්නේ 4 8 8 12 12 16 16 20 ranges 4යි. ඒ වගේම සෙන්ඩිං සිගනල් එක අපි කියන අවට්පුට් සිගනල් එක 0 to 10 තමයි සෙට් කරේ. එතකොට මේ වැලියු එක මෙහෙමනම් මේ වැලියු එක මෙහෙම රේන්ජ් එකක යන්න ඕන කියන එක තමයි ප්‍රෝග්‍රෑම් එකේ ලියලා තියෙන්නේ, right? So when the value is 16, it will give the 7.5 value. Likewise, as you can see in here, when I change that value into 12, 12 means හරියටම half වෙන්න ඕන range. It will give the 4.99 means 5. When it comes to the 8 milliamperes, it will give 2.5 approximately, right? That is the thing. All right. So actually, according to the factory rules and regulation policies, I couldn't be able to share the actual implementation of this project, right? So due to that reason, I'll explain the final implementation by using the block diagrams, right? All right. So there are parameters detecting components like sensors. Uh, Take sensors for an example, and this will sense the signal into the uh, PLC uh, on the range 4 to 24 milliamperes and 0 to 10, right? Volt, right? Then the PLC is converting them into the raw value, right? That actually takes within the range 0 to 27,648 value, right? So that is the raw value, right? Raw value range of the PLC. ඒ කියන්නේ අර කොහොම රේන්ජ් එකේ ආවත් මේක කන්වර්ට් කරගන්න එක 27648යි කියන වැලියු දෙක වැලියු රේන්ජ් එකට. මේකේ මේ රේන්ජ් එකේ ආවත් 4 බිඳුවට ගන්නවා 24 කියන එක 27648 කියන වැලියු එකට ගන්නවා, right? Then it will sense to the PC system, and then the Python program will detect in the signal value from here and from the signal received from the particular pin, right? Particular pin input. The computer program will program actually will know what is the sensor is it, and the what is the value for it. All right. So then by using this model that I've trained, it it predicts the state according to the parameter, right? Then take some decisions. That is the final target, right? Then it will output that values into the PLC system again, and the PLC system will sense that values into the actuators if needed, right? Okay. That is the final outcome of that project, and this actually an implementation of AI automations into uh, somewhat industrial level process driven applications, right? Okay. So there are so many methods that I have used inside that the code to achieve this state, and yeah, due to the lack of time availability, I'll stop from here, guys, and yeah, thank you.